welcome back to another diagnostic video. Today we're going to be looking at a 2004 Jeep Grand Cherokee with a 4-liter inline 6. According to the customer, the problem with this vehicle is it cuts out under load. Anything kind of above 2000 RPM when you're accelerating, they say it cuts out and bucks. Now, when we got this vehicle from the customer, it had a long list of stuff already done with it. They put a O2 sensor in it, crank sensor, cam sensor, map sensor, coil pack. They did the plugs. They even went as far as to hollow out the cats. They thought maybe the cats were plugged up on it. They cleaned the throttle body, and then we finally got involved when they called it for a PCM, and we went down there to program the PCM. PCM didn't fix it, so that's when we got our hands on it. So I think the first thing we're going to do here is scan the vehicle for codes and just see what we got going on there. So unfortunately for us, this is what we found after we scanned the vehicle. This thing was not setting any codes at all when it was acting up. So we kind of had to think about this for a little bit and figured the next step to take was to hook the scope up to it and just see exactly what we're losing, whether we're losing spark or fuel. Alright, what we have here is our scope shot of the coil and injector current. Red is our injector current and blue is our coil current. Now each spot here where you can kind of see it spiking up, that's when the issue is occurring. That's when I'm going wide open throttle in this thing and when it starts cutting out. Kind of looks like a mess now, so let me just zoom in and show you what we found. I don't know if you can really see this here. Let me zoom in a little more. This here, this is our injector. These are all the injectors firing. And every once in a while you can see that the injectors are cutting out. That is, let me put this ruler here just to show you. Pretty close to 0 amps. So it's the injectors on this thing that are cutting out. Let me just go and have a look at the coils just to show you that they are not cutting out. You can see here during the issue the coils are still firing, and it is injectors that we are losing. Now from here we kind of have to think what controls injectors. Primarily the cam and crank signal are what tells the computer the position of the engine, and the ECM takes that and decides when to fire the injectors. So what we did next was hooked our scope up to the cam and crank as well as looking at the injectors. Alright, this next waveform here is our cam and crank, and we also decided to monitor the injector current and injector 1 control. So what we got here, let me zoom in and just see which one's which, because I forgot to label this, so we'll have to zoom in and see exactly which one's which. Okay, so our blue is going to be our cam sensor there, red is our crank sensor, looks like green is our injector current, and yellow is our injector 1 control. Let me just scale this down a little bit so we can fit it all on the screen. Yeah, we'll go one more. Do the same for current, just a little bit. And we can fit it all on the screen. Alright, so you can see here we are losing our injector, but we're not losing injector 1 every time we lose an injector here in current. So this thing is losing multiple injectors. You can see here it's losing injector 1 here. If you move down a little bit, you can see it's losing it there too, but not here, not here, and that's where it stopped there. So this thing's losing multiple injectors. It's not just one single injector. So that kind of, in my mind, rules out any sort of wiring issue unless we have a power issue, but we can see here that we do not have a power issue. If it was a power issue causing the injector to stop firing, you'd see 0 volts here on this main power wire, but it's the control that we're losing, because the ECM just stops grounding the circuit, which is what you see here. So it's control side where we're having the issue. So that's why we decided to take a look at cam and crank. Now if we have a look here where the issue is occurring, I don't really see anything wrong with that cam and crank. It's a little bit noisy, but I don't really see anything wrong with it. But that's not to say that we don't have an alignment issue, and the only way we're going to really be able to figure that out is to find a known good waveform. So that's what we did, and I'll show you on the next screen exactly what that looks like, and we'll compare it to this. Okay, so what we have here is our cam and crank waveform from our problem vehicle and a known good cam and crank waveform. What I've got here are the degree cursors, so I can see exactly how far out of alignment the cam and crank is on our vehicle, if it's out of alignment at all. So if we just go back here to our problem vehicle, I put our first cursor on the leading edge of the the cam pulse, and on the leading edge of the first crank pulse. Now between the two, this crank pulse happens 28 degrees after the first cam pulse, and if we go back to our known good vehicle here, same thing. It happens about 29 degrees before the first cam pulse in our known good. So that's pretty close. That's actually just about bang on. 1 degree or so isn't going to make a difference. It's really not going to affect the vehicle the way we're seeing anyways. So the only thing that we really noticed with our problem vehicle here is these kind of bumps where it looks like it drops out a little bit and looks a little staticky. We weren't sure if that was actually causing our issue, but we did know that the customer put a cheap aftermarket crank sensor in this vehicle, so we decided to go ahead and get an OE crank sensor, put it in the vehicle, and retest. So after putting the OE crank sensor in the vehicle, took it out for a road test, and the thing ran great. It ran totally perfect. No issues with the bucking or cutting out or anything like that. Drove it around for about 30 minutes in town and decided to take it for a good highway run. At which point, literally as soon as I hit the on-ramp, the issue started occurring again. Now we got it back to the shop, and we decided to look at the cam crank again, and we were really trying to figure out what could have happened with this vehicle, why it ran great for half an hour and then all of a sudden just stopped running good after about 30 minutes of driving. And after looking at the waveform here, it looks almost identical. It looks like there's a little bit more noise, but the alignment is the same. Everything looks the same on this. So from this point, we were kind of bashing our heads against the wall with this vehicle. We really were having a hard time making heads or tails of what was going on with this thing. At which point, I just decided to go over the connectors on the ECM one by one, going over the pins on the ECM, just seeing what each circuit was, and kind of thinking about each one, and thinking, how could this circuit mess up the injectors on this vehicle. It didn't take me long before the light bulb went off. I'll just we'll go over to the diagram now, and I'll show you what I mean. Okay, so here we have the wiring diagram for our ECM. And as I mentioned before, I went through each one one at a time here until I came to pin 6 here, which is the park neutral switch. And that's when I saw that, I figured, you know what, if the park neutral switch is messing up in this thing while I'm driving, it could potentially mess up the injectors, or it could cause the ECM to stop firing the injectors. If it thinks the thing's in park, it's not going to let the engine rev out. So. At which point I took the scope and I hooked the scope up to this circuit, as well as looking at the injectors again, and I took it on a drive. Okay, so what we have here, our blue is our injector number 1 control, and our green is our park neutral switch. So the way this park neutral switch works in this vehicle, when you put the vehicle in drive, it ungrounds the switch, and the ECM sees the 5 volts on the circuit. When you ground it, when you put it in park, it grounds the circuit. The ECM sees that voltage go away, and that basically tells the vehicle it's in park. Now if we just zoom in here, you can kind of already see what's going on. This it looks like either the switch or the wiring is intermittently grounding out somewhere. And every time it does that, it cuts out the injectors. Now, it doesn't do it every time, but it's pretty consistent. I'm kind of surprised it wasn't doing anything in here. Let's just zoom in here and see what it looks like. Yeah, I'm actually really surprised. You know what? It could have been doing it here too, because we only had number 1 injector control, so it could have been doing it on other injectors. I don't remember off the top of my head how it was running here, but you can see here that it is definitely cutting off the injectors every time you have that circuit grounding out. Now that kind of explains why this thing ran okay when we put a crank sensor in. My arm, when I was putting the crank sensor in, was rubbing up against the harness because the harness ran near where the crank sensor was. It's kind of a tight space, so I was hitting the harness with my arm every time I would go and put my hand up there to install the crank sensor. So what I'm thinking happened is, or what I'm assuming happened is, this circuit here is intermittently grounding out on a piece of metal somewhere, like a transmission bell housing or something like that. And when I went to go install that crank sensor, it disturbed the wiring and moved it away for a short amount of time. So basically all we did was we went and we just went and cut the wire to see if it made it any better. So we have our injector 1 control here again, and our park neutral switch. This right here is where I cut the circuit, and it went high, and this is me driving it through here, and it did not act up once again. I drove it for quite a bit longer after this, just to confirm. I actually drove it home one night to confirm that it wouldn't act up again, and drove great the whole way. Didn't act up once. Each little spot you see here, that's just me decelerating. That's totally normal, so I'm not going to worry too much about that. What we know was happening with this vehicle, every time it would drop out and think the vehicle was in park, it was rev limiting is why it was cutting the injectors. So when you're in park and you put it to the floor, it'll only rev up to about 4,000 RPM, and it'll just bounce there. And all that does, or all the computer's doing there, is cutting out the injectors. So that's what was happening when we were driving this thing. It thought it was going into park, and it would cut the injectors out. Now with this circuit cut, I tried revving it, and it revved right out to 6,500 RPM. So rev limiting is no longer going to work with that circuit cut. But after doing some reading, that is all that circuit is there for. It has a different tranny range switch to determine whether the vehicle's in park for the gears and stuff like that. This circuit here is just for rev limiting in park, which a little bit weird the way they do it, but that's how that's what was causing our issue. So after we cut that wire, it never acted up again, and the customer took the vehicle back and told us that they were going to try and identify where the problem was, whether it was in the wiring or the park neutral switch. So after all that messing around, it turned out to be something rather simple to fix, but it was kind of a bizarre failure.
If you like this video, please let us know by following us or liking us on Facebook, Instagram, Twitter, and YouTube. And if you want access to more in-depth training videos, please visit our website at www.autoaid.ca. Thanks for taking the time to watch this video.